Hello students, today we are going to see some more interesting and important questions from Narendra Avasthhi sir's Physical Chemistry Redox Reaction Level 2. Come on, let us discuss few more questions from this session. Here the first question, conversion of oxygen to ozone occurs to the extent of 15% only. The mass of ozone that can be prepared from 67.2 liter of oxygen at 1 atmospheric pressure and 273 Kelvin. So they have given that volume based. So that means when we go and identify that number of moles of oxygen, so given volume by molar volume, so that we will identify the number of moles of oxygen prepared from 67.2 liter, that we will identify. And the second one, conversion of oxygen to ozone occurs. So this also we can identify from this mole into given mass. So automatically we will get that what it is, moles of oxygen conversion point. And the third one, finally, through stoichiometric equation, we will identify the mass of ozone. That is a comparison between this and this we can identify. Come on, let us go and deal this up. So the first point what I wanted to mention, moles of oxygen. So here moles of oxygen. So moles of oxygen, what is the formula here? We can write it given volume, right? So here given volume by molar volume, right? So given volume by molar volume, given volume how much? 67.2 liter by molar volume 22.4 liter. So you will get 3 moles, right? So now here a conversion of oxygen to ozone, how much it has taken percentage wise. So conversion of oxygen, that means moles of oxygen converted. So moles of oxygen converted, how much it is here? 3 moles into 15%. So 15%, so we can write it 3 into 0.15. So we will get how much here? We will get 0.45 moles, right? Now third step, what it is? Equation, stoichiometric, right? Balanced chemical equation. So oxygen O2 can convert it to O3. So that means here 3 moles of oxygen can convert it into 2 moles of ozone. So therefore 0.45 moles conversion, how much it will be? That is only the last point. So 3 moles of oxygen can give 2 moles of ozone. Therefore what it is? 0.45 moles of oxygen. Here oxygen can be, so here what is it? 2 by 3 into 0.45, right? Got it? Now what is the answer you will be getting? So you will be getting around 0.3 moles, 3 moles, right? So 0.3 moles, how do we get that mass of ozone? So mass of ozone, so mass of ozone equal to what it is? What is the mass of ozone? Here oxygen 3, 16 into 16 into 16. So that means here 48 gram per mole, no? Mass of ozone. So that means here moles into molecular mass. So moles into molecular mass. So moles into molecular mass, how much it is? 0.3 moles into molecular mass, 48 gram per mole. Right now here, what is the answer you will be getting? You'll be getting around what it is? 14.4 gram. I hope you got the clarity. Yes. Come on, let's go to the next question. Now let us see the option it is. Actually, the option it is 14.4 gram. Yes, first answer only 14.4 gram. Yes, got it. So 14.4 gram. See, purposely I just bring that answer also, related discussion answer also I just bring it. It is a very shortcut, but this mole of ozone formed, this is 15 by 100. So easy to understand. I just explained it this way, right? The conversion of moles into 15% into 3 moles. So instead of this shortcut method, I have explained in a long process. I hope you got the clarity. Come on, let's go to the next question. The next question, RH2 ion exchange resin can replace Ca2 plus ion in hot water, as RH2 plus Ca2 plus it gives RCa plus 2H plus. If 1 liter of hot water after passing through RH2 has pH equal to 3, then hardness in parts per million of Ca2 plus S Actually, come on, let us check how the question. Now, this is ion exchange process, right? Okay, ion exchange process in the sense here I will write the equation so that you will understand very clearly. So, RH2 plus Ca2 plus, it gives what it is, RCa plus 2H plus. Right. Now, here in this 1 mole of Ca2 plus, I just mentioned in wording so that it will be easy for you to understand. So, 1 mole of Ca2 plus ion can be replaced by 2 moles of H plus ion. So, can be replaced by 2 moles of H plus ion, right? Now, here, that means here molar concentration of calcium. So, molar concentration of calcium is initially present. It's exactly half of the molar concentration of H plus ion. So, that means here Ca2 plus is equal to half of the H plus ion. I hope you got the clarity. So, Ca2 plus, it is 1. So, half of that H plus ion. Right now, the next point here, I would like to give that hydrogen ion concentration. Hydrogen ion concentration. Hydrogen ion concentration. So, hydrogen ion concentration, here how do we identify? Here actually pH equal to 3 they mention. Generally, what is the formula for pH? Minus log 10 H plus ion, concentration of H plus ion, that is equal to 3, right? So that means H plus ion. So that means here what it is? H plus ion, concentration of H plus ion equal to 10 to the power of minus 3. Can we bring it in that way? So this is actually what it is? Mole per liter. So can we bring it in this way? 0.001 molarity concentration? No. So molarity we can bring. Now the second point what I wanted to mention, Ca2 plus. Ca2 plus equal to half into 0.001 molarity. You will get what it is? 0.0005 mole per liter. Mole per liter. Yes, got it. So, molarity to parts per million. Now, we have to convert. Okay, molarity to parts per million, ppm. So, how do we convert? Hardness in ppm. It is we convert molarity into milligrams per liter. Molarity into milligrams per liter. So here in this point, here we have to consider what it is. Molar mass of Ca2 plus. How much? So molar mass, calcium only here, it's ions only, no? So that is what. So here atomic mass also you can bring it. So I just bring it. Molar mass of Ca2 plus. It is actually 40 gram per mole. Right now here, Ca2 plus mass of Ca2 plus equal to molarity into molar mass. Molar mass, right? Molar mass. So what you will get it here? Molarity just now we found now. So what is it? 0.0005 molarity into molar mass. It is 40 gram per mole, right? It's 40 gram per mole. Right. So you will get what it is. Mass, how much? It is 0.02. So mass of calcium, it is 0.02 gram. Right. I hope you got that idea. Now convert into milligram. So convert into milligram. So milligram, what it is? 0.02 gram. Gram per liter into 1000 milligram by gram. So you will get how much? You will get 20 milligram per liter. So that means here what it is, as we observe here, 20 ppm, 20 parts per million. I hope you got the clarity. Now what is the correct option? I hope you got an idea how to convert into what it is, concentration into ppm, that is molarity into ppm. And the second one here, what it is, conversion of milligram into gram per liter. Then finally we are bringing ppm, right? So which is the correct option? Option 20. Option A is the correct option, right? So here also I just to bring that what it is answer here, so that here concentration of H plus directly they have given what it is 10 to the power of minus 3 molarity. So Ca2 plus equal to half of that hydrogen. So that the equation, no, what it is considered, this equation Ca2 plus per calcium, that means Ca2 plus ion is equal to half of that H plus ion. That is what? Half into 10 to the power of minus 3 molarity. So you are getting this mass. So you will just apply on the whole with it. This is also easy only. So whichever method for you to understand, you can. This is a little bit longer method, but still you will understand. That is the reason I just to bring it to you. I hope you got the clarity. Come on, let's go to the next question. The next question, 100 centimeter cube of a solution of an acid, molar mass, it is 98 gram per mole, and containing 29.4 gram of the acid per liter were completely neutralized by 90 centimeter cube of aqueous sodium hydroxide containing 20 gram of sodium hydroxide per 500 centimeter cube. The basicity of the acid. See, it's very simple. First and foremost, we have to find out what it is, molarity of acid and base, and then we can go and identify number of moles of acid and base. Finally, we can identify basicity of the acid. You know, what do you mean by basicity of the acid? Number of H plus ion replacing. So that is called basicity of an acid, right? Volumetric analysis we have gone through, right? The same idea. Come on, let us go and identify here. Basicity, I just mentioned that point over here. Basicity of an acid. So basicity of an acid, what it is? Number of replaceable H plus ion per molecule, right? So number of H plus ion per molecules, that is called what it is, basicity of an acid. Okay, now let us identify the data what they have provided. So the acid solution contains, the acid solution contains how much gram per liter they mentioned? 29.4 gram per liter they mentioned. Right now here, molar mass, how much they have provided? Molar mass, how much? Molar mass of an acid, how much it is? Actually 98 gram per mole. Right, now easily we can identify the molarity of an acid. How to find out molarity of an acid? Mass per liter divided by molar mass, you will get molarity of an acid, right? Come on, mass, what it is? Molarity of an acid. So molarity of an acid, what it is? Mass per liter divided by molar mass. Right, mass per liter by molar mass. So that is called what it is? Molarity of an acid. Can we apply the values over here? Mass per liter, that is acid contains 29.4 gram per liter and molar mass it is 98 gram per mole. Okay, so can we apply that value? 29.4 gram per liter divided by 98 gram per mole. So you will get what it is? Molarity of an acid. What is the molarity of an acid? When you calculate this, you will get what it is? 0.3 molarity, right? Molarity of an acid, 0.3 molarity. That is concentration of an acid. So volume of acid, how much they have given in that question? Starting only they have given 100 centimeter cube. So we converted into liters. So volume of an acid. Volume of an acid solution. Volume of an acid solution, what it is? 100 centimeter cube. So we just converted 0.1 liter, right? 0.1 liter. Right, now we can identify the moles. How to identify the moles? Moles equal to molarity into volume of solution. We'll get moles of the acid, right? So moles of the acid or moles of an acid. So moles of an acid, what it is? Molarity into volume of solution in liter. Molarity, just now we find 0.3 molarity and volume of solution in liter, that is 0.1. Okay, so that is acid number of what it is, sorry, moles of an acid we can identify. That is molarity 0.3 into 1 liter. So we will get what it is? 0.03, right? 0.03 moles. So number of moles of an acid also we found. Molarity of an acid also we found. The same way, let us go and identify the base. So the same base contains molarity. So base, the base solution contains, they also have given what it is. All the particulars about that is 20 gram per 500 centimeter cube. Right now here they mentioned, and that acid and base in the question they mentioned, 20 gram of sodium hydroxide per 500 centimeter cube. The same way here 29.4 gram per acid, that is acid per liter. So here they have given 500 centimeter cube. Okay, now let us go and identify the molarity of the base. Okay, finding the molarity, we have to find out mass per liter. Why? Here base solution contains 20 gram per 500 centimeter cube only. Right now here mass per liter. So mass per liter. So we have to convert that into liter. So this is 20 grams into volume of solution in liter. So this is volume of solution divided by liter. So automatically it goes up. So this is actually 1000 divided by 500 centimeter cube. So you will get mass per liter. How much? You'll be getting 40 gram per liter. You'll be getting. Right now, molarity of sodium hydroxide, it will be easy for us to identify. So molarity of base. Molarity of base. The same molarity of acid we mentioned, the same way molarity of base. So molarity of an acid, how do we identify? What is the formula? We brought it just to check it once again. Mass per liter by molar mass. The same idea we can bring here. Mass per liter. So here mass per liter divided by molar mass. So mass per liter, how much? Mass per liter here 40 gram per liter, no? So 40 gram per liter divided by molar mass of sodium hydroxide. Sodium hydroxide, it is 40, right? So 40 gram per mole. Right now here we will get that molarity. So how much you will be getting? 100%. That is 1.0 molarity M only. So molarity of an acid, molarity of base we found. Moles of sodium hydroxide, that is moles. Moles of acid also we found. Moles of base we have to identify. Moles of base. So moles of base, what is the formula? Molarity into volume of solution in liter. Volume of solution in liter. So molarity, what it is? 1. And volume of solution, it is how much they have provided? 90 centimeter. That means it is completely neutralized. They mentioned 90 centimeter cube. So that means here 90 only. So 90 we have to convert it into liter. So 90 centimeter cube means here we just converted 90 centimeter cube. So it is 0.09 liter. Right. So 0.09 liter. So you will get what it is. This is molarity and liter. So you will get what it is? 0.09 moles. So we found that acid moles and base moles. Now we can find finally the basicity. So basicity is what it is? Basicity of that acid. Okay. So basicity. Wait a minute. Basicity. Okay, so basicity equal to what it is? Moles of base by moles of acid. Moles of base by moles of acid. Moles of acid. Right. So moles of base and moles of acid equal to what it is? Moles of base, what it is? 0.09 moles. Right. And the same way moles of acid, what it is? 0.03, right? Moles of acid 0.03, right? Moles of acid, it is 0.03, correct. Yes, got it. Okay, 0.03 moles. Right, now what it is? You will get 3. So basicity of an acid, it is 3, right? Basicity of an acid, okay. So basicity of an acid, it is 3. Okay, answer we are getting 3, but still we are having that doubt what acid it is actually, because 98 gram per mole, molar mass 98 means it is 100% what we can think it is king of acid. What it is? Sulfuric acid. But some other acids also it is possible. I just wanted to give that idea. Monobasic means here 1 mole of acid, 1 mole of base. Here just I want answer it as 3 only. So this is indicating tribasic. That is what I wanted to bring here. So here monobasic. So monobasic means here 1 mole of acid and 1 mole of base. So that is what it is? Monobasic acid. And dibasic acid means, so here dibasic. So dibasic means what it is? Here 1 mole of acid, 1 mole of acid and 2 moles of base. Here what it is? 2 moles of base. And the same way next one, here tribasic. So tribasic means what it is? 1 mole of acid, 1 mole of acid and what it is? 3 moles of base. 3 moles of base. So here in this this is indicating tri-basic. So 3 moles of base. So now here basicity, how much we are getting? Basicity we are getting how much? It is 3. So 100% this is actually what it is. Tri-basic acid. How do we identify tri-basic acid? So here monobasic means 1 acid and 1 mole of an acid, 1 mole of a base. Dibasic means what it is? 1 mole of an acid and 2 moles of base. Basic means it is nothing, basicity only. See, that is what I hope you got the clarity. So here we are talking about basicity of an acid. So basicity of an acid, basicity. I just mentioned that is also because you'll be getting confused. Basic, basicity. So basicity. So dibasicity and tribasicity. So basicity 1 mole of an acid and 3 moles of base. Okay, now let us reveal what type of acid, what is the acid exactly it is. Actually, sodium hydroxide, what it is? NaOH only. And acid, tri-basic acid, so that means here H3PO4. It gives what it is? Na3PO4 plus 3H2O. So here what it is? Na3PO4, so 3. So that means here what it is? So 3 moles of sodium hydroxide and 1 mole of acid. 3 moles of sodium hydroxide and 1 mole of an acid. It gives what it is? Sodium phosphate and water. Right, acid and base, you are getting salt and water. Now, what is the molecular mass of H3PO4? It is 98 gram per mole. I hope you got the clarity. Finally, we reveal that what it is. Orthophosphoric acid also is having what it is? 98 gram per mole, that is molar mass. Right now, what kind of acid it is actually? 3 moles of base, that means a tri-basicity of an acid. So how do we identify? So it is that is what I just bring. Monobasic means 1 mole of an acid, 1 mole of base. So that means NaOH and HCl. Right, dibasic here. Dibasic is what? Dibasicity is what? 1 mole of acid, 1 mole of base. So that means here what it is? H2SO4. See, basicity it is nothing. Number of H plus ion replaceable. I just bring it here, that idea for you to understand. So 1 mole of an acid. So that means HCl. So only 1 HCl, H plus ion replaceable. Here H2SO4. So that means 2 H plus ion replaceable. Here tri-basicity. So 3 moles of base. So that means here what it is? H3PO4. I hope you got the clarity. How do we identify the answer? See, these are all practice makes the man perfect. So as we go through this once again, we will come to know the clarity about this topic. And yes, come on. So which is the correct option? Option A is the correct option. 3 moles of base. So basicity it is nothing. Number of H plus ion replaceable. So 3 moles of base can be eligible to replace 3 H plus ion. So how many sodium hydroxide is there? So how many OH is available? That many H plus ion replaceable. Why? Because acid and base gives salt and water. Right now, that is what here they have provided. Here N1V1 equal to N2V2. They have given another idea, but I have elaborated completely what is basicity. How do we identify step by step? I think I have given. I hope you got an idea. Maybe it is extending little more, but I hope you understand that point. That is, I hope. Okay, come on, let's go to the next question.